So I'm a recent graduate and I'm just going to talk a bit about what I did in my honours work, so as a mathematician. So we've had a little bit of an introduction to coral polyps, but I'm going to tell you a little bit more about them. So as they do look a bit like jellyfish, I also would like to call them aliens because they kind of do look like something that's not from this planet when you take a really zoomed in picture of them. So there's thousands and thousands of these little coral polyps that make up what we think of as coral branches and mounds. And when we sort of look at those tiny little creatures, you wonder how they can build up that huge Great Barrier Reef. And the way they do that is they work together to put down their skeleton. So the skeleton, as Juan touched on, is super, super important for the ecosystem itself. So when they put that down, it sort of looks like this rocky thing in here, and it builds up a habitat where fish can hide. And it also helps humans in ways like coastal protection because it slows down the waves as they come into the coast. So these polyps that are putting down that skeleton are super, super important. And we really need to look at the way that they're growing and in which conditions in order to get a good sense of how the reef is going. So let's look a bit at the way they build their skeleton. And this is going to be a very, very basic approach to looking at it. So the way these alien-looking polyps build their skeleton is they take in the building blocks in the seawater. So this is the different molecules that are available to them. So they have calcium and they have elements from the carbonate system. So a lot of different molecules mixed up in this chemical soup of a sea. And the polyp takes in the seawater and it uses those building blocks to build its skeleton. So inside the coral polyp is chemical reactions like photosynthesis with those algae that live inside it. And we can sort of look at this reaction that produces the skeleton as a calcification reaction. So that's what puts down that skeleton that builds up the reef and provides such a nice habitat. So why am I a mathematician looking at coral? Well, long story short, because we want to predict how well it will grow in different environments. So send in the mathematicians. We're going to use our different environmental conditions, which we can measure. So what's in the water, what our temperatures are, our light availability. And we try and create models that show the chemical processes that occur inside the polyps. So this includes all those reactions and the way that it flows through the coral polyp. And we can use that to come up with a prediction for how quickly it's producing its skeleton. But why would we bother doing this? Well, because it creates a really good measure for how our coral reef ecosystem is doing. If we can see how well the coral polyps are putting down that skeleton, we can sort of have a good idea as to how healthy it is. So this is really important for predicting the way that coral grows in different environments. So if we look at the different water conditions and light, we can sort of make some sort of informed guess as to how well the coral is going to grow, which is really important when climate change affects our oceans. So if that chemical soup of molecules changes, then we need to be able to understand the way that this is going to affect our coral. So that's a really quick snapshot of my research here at QUT, and I hope you all enjoyed it.